Okay, so real quick, I want to go back over the writing the equation of a sinusoid. So we said that when you want to write an equation as a sine function, you would write y equals a plus b sine c times theta minus d, where a is the horizontal center line, b is the amplitude, c is 360 divided by the period in degrees, or 2 pi divided by the period in radians, and d is the phase angle, which is the value closest to the y-axis, where the curve crosses the center line on its way up. Everything is the same for writing the equation as a cosine function, except when you look at the phase angle will be the maximum value of the function that happens closest to the y-axis. So let's look at this example again. We want to write this as both a sine and a cosine function. So first of all, the first blank that we need to fill in is the midline. So to find out what that center line is, that horizontal line that goes right through the middle of the function, we need to look at the maximum and the minimum. At maximum, this function is up at 7, and at minimum, it's down at -1. So halfway between those two is going to be where that center line is. So the distance between 7 and -1 is 7 minus -1, which is 8. And then half of that is 4. So we know that if we go up from -1, 4 spaces, we'll get to the midline. If we go down from 7, 4 spaces, we'll be at the midline. And so -1 plus 4 is 3, which is the same thing as 7 minus 4. That's 3. So 3 is that center line. It is the line y equals 3. So that is the center line, and that's what goes into the first blank. All right, the second blank is for the amplitude. The amplitude is the distance from the center line to the maximum of the function or the minimum of the function. It's the same amount, and that we already just found out is 4 because it's halfway from the minimum to the maximum. And so that's the amplitude. So we put that in right in front of each function. And then we have to figure out the period. The period is the distance that it takes this function to do one cycle. And it could be, you could measure it from, any place you want to, but if you don't want to make that decision, here's an easy way to do it. It's just to go from the maximum to the next maximum. And if you do that, you'll notice the first maximum there is at -90. The second maximum is at 450. So if you subtract those two numbers, you'll find the distance between them, which is 540. So that's how many degrees it takes for this function to complete one cycle. We want 360 over the period, so that's 2/3, and we will put that in that blank. All right, so the phase angle. For the sine function, we're looking at the place where this function crosses the midline on its way up. So that's there at -225, so our phase angle is -225. We can call it the phase shift. And so we would say theta minus -225 for that. And then for the cosine function, your phase shift is the place where you have a maximum closest to the y-axis, and that happens at -90. Right there, that's where the top of the function is closest to the y-axis. So the phase shift for the cosine function is -90, so it's going to be theta minus -90. And that is the same as theta plus 90, and theta minus -225 is the same as theta plus 225. So that is how you would write this function as a sine function and a cosine function. Okay, now we're going to talk about antilogs. We know already how to write things in exponential form and logarithmic form. So when you have exponential form, you have base raised to the power equals the number. So I'm just writing it as b for the base, L for the logarithm, which is the exponent or the power, and n we're calling number. And so we call b the base, L is the logarithm, the power, and then n actually has a name, and it is the anti-logarithm. So the three things in the exponential form and the logarithmic form they all have real names. So the base is the base. It's either you can see where that's located in both forms. And then the logarithm is the exponent, and you can see where that's located in the logarithmic form and in the exponential form. The number, the thing we've been calling number, is actually called the anti-log. All right, so all we're really doing here is getting our terminology straight. These two forms give you the exact same information. They tell you a base, they tell you a power, and they tell you what number you get when you put the power on that base. It's just a different order, and it is two different functions. In one of them, you're given a number, and you want to find out what power you would have to put on the base to get that number. In the other form, you are given the base and the power, and you want to find the number. The anti-log is going to seem really obvious. So when I say, if the base is 2, find the anti-logarithm of 4.63, what that's telling you is the base is 2, the log is 4.63, and we want to know what the anti-log is. So basically, in this question, 4.63 is the logarithm, or the power. So you're just raising 2 to the 4.63 power to see what anti-logarithm you get. And to do that, you would just punch this into your calculator. You would hit 2, and then you'd hit y to the x, and then 4.63, and equals, and you would get about 24.76. So same exact order of operations when you do the next one. It says use a calculator to find the anti-logarithm of 4.63 if the base is 10. So basically you are saying 10 raised to the 4.63, same order of buttons, and that would give you about 42,657.95. If you want to find an anti-logarithm with a base of e, you would use the e to the x key that you can see is the second function right above the ln function. So if you're trying to find the base e, anti-logarithm of 4.63, you're finding e raised to the 4.63. You're trying to get the number, the logarithm, the anti-logarithm, sorry. So to do that, you're just going to hit 4.63, and then you will hit inverse e to the x, or e inverse ln, and then you'll hit, it will just come up. So it'll be about 102.51. And then the last example says write the value of e to 5 decimal places. And to do that, you're just going to pretend that you're finding e to the first power. So you'll hit 1, and then you will hit inverse e to the x. And that will give you about 2.71828.